On this channel, we like to get as many people involved as possible from the world of cleaner, greener, safer, and smarter transportation. Sometimes that means us talking to people at events. Sometimes that means us reviewing cars and talking to people who are influential in the industry. And sometimes it means just a good old-fashioned interview. If you watched our interview a couple of weeks ago, you will know that we had Peter Rawlinson on, the CEO of Lucid, and we've got some other great interviews lined up for you in the not too distant future. But today we're talking to a guy who has been heavily involved with General Motors' electric vehicle push. He is, in fact, chief engineer for Bolt EV. Please welcome Jeremy Short to the show. Jeremy, it's great to have you here.
Thank you for having me.
First up, I just want to make sure that you and yours are all safe at this really tough time in the United States. I hope that you've all been able to continue work and stay safe where you are.
We are getting used to it. It's been a little while now. I've been relegated to one room in the house, and the wife and 3 kids are running around. But I have them put away for now, so hopefully you don't hear them, and hopefully nobody walks by the door.
It's okay. We're all in the same boat, Jeremy. So, Jeremy, let's start by talking about your history in the automotive world. Just like our interviewee, Peter Rawlinson, a couple of weeks ago, you have a long and distinguished career in the automotive world, and it hasn't always been battery electric vehicles. So let's start there. Where did you start in the automotive world?
I would say that I started in chassis. So I actually started as a brake engineer. Started with park brake, actually, and grew responsibility from there. Went from park brake to brake corners, eventually picked up every aspect of the brake system. Later on, I was a brake system engineer for the full-size trucks in the late 2000s, if you will. And then I moved over to mid-size sedans. And then I joined the program team where I worked on Malibus and Impalas and expanded from chassis and started working in other aspects of the vehicle. So while I came from chassis and brakes and at some point suspension, a lot of the same engineering disciplines are applied as you apply it to other parts of the vehicle. So it was a natural growth, an organic growth, if you will, through the vehicle development process. So that's been about 10 years ago. I joined the program side, did, like I said, Malibus and Impalas. One of my babies was a 2016 Malibu. Then I went over to full-size trucks for a while, and now I'm over in battery electric vehicles.
So it's quite a change, obviously, to go from trucks to battery electric vehicles. But with your background in chassis technology, obviously battery electric vehicles do have a very different handling characteristic to, your traditional internal combustion engine vehicle. That's obviously thanks to the super low center of gravity that's afforded by those batteries low down in the vehicle, but also the way that vehicle responds on the road, because the mass is in a different place. So how have you been able to use your time in the truck side of General Motors to help improve the Bolt EV in terms of where it ultimately ended up?
Of course, they're 2 different vehicles. They're used in different ways. One is known for its cargo capacity or towing capacity, and another one, like you said, is low to the ground and a substantially lower center of gravity. So while those suspension bits are different, they're different in size and in some cases different in what they actually do for the vehicle. The process in which we develop them and the way we validate them are more similar than you would think. We don't have the off-road requirements that we have on the full-size truck, but we do a substantial amount of validation, which has us abusing parts and trying to break them in the lab so that they don't break out in the real world. As far as what I've learned, really what I learned from full-size truck was those customers really know their vehicles. It was always interesting to me to talk to them because in some cases I would actually learn from them, maybe not so much in the hardware, but in how they used it. You design it one way and you send it out into the world. It's like having a baby, right? you have a baby, you raise it, you teach it all these things, and you send it out in the world, and it comes home from college, and you're like, wow, I don't know where it learned that. So talking to customers, we always learned a little bit about how they used it. And when I got to electric vehicles, it was very much the same way. The customer was very educated on the product, and we try to emulate how they would use it, how they would go and charge it, how they would drive it, all these things. But really, what I learned from truck was to go talk to the customers, read what the customers have to say, and doing that same thing for the battery electric vehicles. I've often been surprised and delighted in how they use it.
So let's talk about, some of the development of the Bolt EV program. Obviously, the Bolt EV has been with us since the 2017 model year car. We saw the concept before that, obviously when it debuted. The concept vehicle obviously being very different to the actual production version, certainly in terms of the interior, but in terms of overall design language, it's a very similar car. So can you talk to us about the process generally that happens? Because I think a lot of people don't understand how the automotive industry goes from an idea to make a car to a concept vehicle to an engineering prototype, through the various iterations to production intent, to body in white, to pre-production validation, to finally driving off the dealer lot. That's quite a long process, right?
Right. You mentioned many of the highlights, actually. A concept vehicle, we don't always have a concept vehicle in our programs, because like in a Malibu or in a Chevy Silverado, people know what to expect. They know the general shape, they know the general size. But when the Bolt EV came out, there was a concept vehicle. And concept vehicles are supposed to be aspirational, but they also have some truth to them. So we have design elements that we put on a concept vehicle, knowing that it's close to what the production is going to be. And there's other things that we put out there that, are a little more out there to see how the customers and the public would react to certain design features. So when we start with a concept vehicle, there's not a lot of engineering behind it. Most of them propel themselves now. But some of them, if you walked up to them in a car show, they don't even have seats. They certainly don't have a 66 kilowatt hour battery in them, and these things. So they're all a little different. So from a program standpoint, what we really start with at the design center is a theme sketch. It could be a 2D drawing, it could be a 3D drawing. Eventually that becomes a clay, which is milled in 3D, of course. We find some imagery that we like, some design aspects that maybe we took from the concept and we wanted to integrate into the production vehicle. And then we bring in the component engineers, and we have to put some structure behind it. So if you can imagine drawing a picture of a house, draw a picture of a house that you like, and then after that we got to come in and draw the 2x4s and the joists and everything behind it. And sometimes it works the way it was in the clay, and in some cases we have to make adjustments. So after that phase, our theme refinement, we go into a phase where we actually produce the components. We either do prototype builds, or depending on how confident we are, we'll do a pull ahead production tool. We'll get those components on test, validate them as components before we actually build up an entire vehicle. So we'd call that an integration vehicle. So we build a few. These are the vehicles that you'll see on the road that are very heavily camoed, wearing stickers or what I like to call the tuxedo, that black vinyl wrap that you see all over it, which makes it very difficult to see not only what vehicle it is, but even what brand of vehicle it is. So we enter the integration build phase, and that's where we build entire vehicles. These are mostly pull ahead production parts, but sometimes they're prototype parts as well, but they come from those validated individual components. So we build up entire vehicles, and we put those on test. Those become our calibration vehicles. They become our ride and handling performance development vehicles. They become our electrical verification vehicles, and they become our full vehicle durability vehicles, which we put on a durability test. We drive them around with all that camo on there. We have drivers that drive through potholes, drive up and down hills and over. We have what we call the Belgian blocks, which shakes the vehicle somewhat violently. And what we're trying to do is try to accelerate age into the vehicle so we can see how the vehicle will react to the real world over time. So as we're going through this, we're always doing a little iterative design work where we're updating the vehicle, we're making changes. We try to keep that to a minimum. And then we go into a phase where we actually take the vehicles out in the real world. And we'll call it a buy-off ride. I did one not too long ago where we'll drive out to some city and usually try to find some mountains or some backdrop that we don't have in Michigan. And in the case of a battery electric vehicle, we go and we use public chargers, we use public fast chargers. We try to get out there in the real world, but still with the camo on there. And then eventually we get to a point in the validation process, the development process, where we would consider it saleable. We would generally have a reveal. So you have like a concept vehicle, and it's now been a couple of years. We've done all this development work, and now we have an auto show or an event where we actually reveal the vehicle as it is in its production form. And after that, we take off the camo and we build the highest fidelity vehicles, and we put them in what we call our captured test fleet. And we have our employees, not just engineers, but folks from all around our business, drive them for a period of time to accumulate miles. And the whole idea here is that we fully validate the vehicle before we sell it to a customer, so that the customer isn't finding things for us, and we limit that possibility as much as we can by exposing it to as many people as we can, as many miles as we can, as many situations as we can. And that's why that process, while from the outside might seem like a long period of time, but in reality, it's pretty close packed, especially considering some of these longer lead items, longer lead vendor tools, these harder steels that pump out a part every minute or so. Some of these have 52 lead weeks. That means that by the time we finish the design and we kick off a supplier, it takes a whole year for them just to produce that tool in a form where it's dimensionally correct and is strong enough to withstand being used every minute of every day.
And I think it's really important, isn't it, Jeremy, to understand that people's view of how long it takes to develop a car is very different to what the reality is if they don't happen to work in the automotive industry. And as you noted, that that point where the vehicle is revealed either as a concept or as a pre-production vehicle on its way to production, there's still a significant amount of time during which testing and validation carries on. But at the point you first see the vehicle as a member of the press, as a member of the public, that vehicle has been in development for a really long time. I mean, one of your rivals across the road sort of thing with Ford. I've talked to Ford about one of their vehicles that's in development and talked to some of their team off the record, and they've talked about a vehicle that they're working on and how excited they are for that vehicle that we know is coming, but nobody's seen it yet because it's still a year, maybe slightly longer, away from a production debut. And I don't think I broke any trade secrets by saying that, but that's a fairly common thing, isn't it, in the automotive world?
I think most people have seen our camouflage vehicles on the road. You get a good picture of it, and we always consider it a success when I've seen spy photos, if you will, of my own vehicle, and I'm not entirely sure which one it is. So that tells me that the camo is doing the job. But from a communication standpoint, from a marketing standpoint, there's benefits of talking about it sooner, and there's benefits of talking about it later and having it be a surprise. I mean, we could come out and surprise you with what we're going to have in a couple of years, but then you have to wait. But we play this game where we try to hold on to our development cars as close to us as possible, and then once we show it to you, then you don't have to wait so long. So different programs have different needs, different criteria. So the story is always changing, but we've done it always.
And I think that's another really important thing that you brought up, is that different automakers will do things differently, and different projects within the same company will be run in a different way, depending on whether the vehicle is cutting edge and you need a little bit of extra time to make sure that everything is 100% before you reveal it, or whether it's just a mild refresh to a vehicle that's coming down the pipeline that everybody really knows about anyway. Which brings me, I think, probably to the Bolt EV. We have seen this car now on sale. This is going to be the fourth year this December that it's been available in the United States. But the Bolt EV is not a vehicle that is just available in the United States. The way that the Bolt has been designed has remained fairly traditional in some aspects in terms of the design. I know that you had a global team, a British designer working on the physical appearance of the vehicle, but GM also had a pretty unique and new way of developing parts of the vehicle with your tier one parts suppliers. Perhaps you can tell us a little bit about why that was significantly different in terms of the drivetrain and the battery pack and some of the interior electronics.
Yeah, so in our traditional business, we're called General Motors. We were known for building our own engines, our own transmissions, and putting those together and then shipping them straight to our vehicle assembly plants. Well, now we're dealing with some newer technology, and there's a lot of battery devices out there, cell phones and laptops being obvious choices there. But when we left the comfort of that expertise and started growing our own expertise, it was smart on our part to go out there and look for a partner in this space. And we did just that. And while, they had some of the chemistry background and some of the process background, we had the experience in putting in a vehicle and building a vehicle around a pack that was built for a dedicated EV platform. We also had insights on how to mass produce and build these at a rate that had never been done before. So there's only a couple of manufacturers out there that have built as much as us, and part of that has been our ability to exercise our joint venture and produce cells and packs at a rather impressive rate.
Now let's talk about the battery and the battery pack for Bolt EV. Obviously, a lot of companies are relying on third-party battery suppliers, as General Motors currently is, to bring in cell expertise from outside the automotive industry. Because let's face it, traditional OEMs are building electric vehicles and they don't have the same level of historical background in electric vehicles as they might with a V8 or a V6 engine or even a four-cylinder engine. And so where General Motors decided to venture with LG Chem was to partnership with the company on making enough cells for Bolt EV production. And before that, obviously, the Volt. A lot of companies are not doing that. A lot of companies are just buying in the cells and then assembling the packs and going on. And they have had issues with battery cell supply. Is GM's ability to just keep making bolts primarily thanks to the fact that, GM had the forethought to go, we need to be making our own cells in collaboration with LG Chem?
Yeah, so our vision is a full electric future, and there's really no way to do that if you're fully dependent on somebody else, somebody else's technology. So in order to get the volume we need, to do the development and advances we need, to bring the economics of that volume down, it was important to bring some of that in-house and have a partner that worked closely with us, so that we're not so much asking them to do the heavy lifting. We're not carrying the heavy lifting, we're carrying it together.
So the 2017 through 2019 Chevrolet Bolt EV debuted with a 60 kilowatt hour battery pack. It's been pretty popular in the marketplace. It's had a little bit more competition towards, 2018, 2019 that it didn't have in 2017. It was really one of the first long range non-Tesla EVs in the market that was reasonably easy to get hold of if you happened to live in North America. Different kind of results in Europe because of the partnership and the switch of ownership over the Vauxhall and the Opel brands, which, I'm not going to go into there. It's still available in Europe as the Opel Ampera E, but here in North America, sold reasonably well. Really became a flagship for electric vehicles at GM. But then in 2020, there was a few tweaks made, increased the battery capacity by 6 kilowatt hours, made a few other tweaks and nips and tucks. And a lot of people turned around and said to GM, well, that upgrade is a real small upgrade. It's not going to make a big difference. And I've heard several commentators essentially accuse GM of just knocking up that range a little bit in order to remain competitive in the marketplace. The underlying tone of which is, why aren't you giving us a larger battery pack? So maybe you can talk to us about some of the changes that you don't see underneath in the battery and some of the other things for the 2020 model year.
Yeah. So honestly, when we started out with the Bolt EV, the goal was to be the first long-range, affordable battery electric vehicle on the market, and we were able to accomplish that. That was, it was under $40,000 in the U.S. It was over 200 miles. Even was a big accomplishment at the time. We made 238 EPA estimated range in 2017. And what we've learned since then, in the years that came after that, was we were able to make some chemistry modifications. And what that did was increased the capacity of each cell, but it also reduced the internal resistance within each cell. And the result of that was a 21-mile increase in EPA estimated range. It also gave us some improved DC fast charging performance. And we did all that without adding costs to the vehicle. So this wasn't something that we went out there and tried to sell, hey, we're going to give you added range, or we didn't call it the Bolt EV long range or anything like that. We were able to add this to the process that we were already running. We fully validated it, much to the process that we discussed earlier, treated it like a new program, gave it all of the testing it deserved, and we put it out there without increasing the price. So it was never a game with the numbers. This is us living and learning in the electrified space, and there's perks to being one of the leaders and the first in this segment, and then there's other parts where we get learnings along the way, and this was a learning along the way.
You touched on the improved charging for the 2020 Bolt EV compared to previous generation or previous versions. I'll ask that again. So you talked about the improved charging for 2020 model year Bolts compared to their predecessors. But GM did not increase the maximum charge rate of Bolt EV in terms of how many kilowatts it can onboard. We're now living in a world where 150 kilowatt CCS quick charging stations are becoming the norm. We've even started to see a rollout of a much higher power rate at charging stations, 300 plus kilowatts. Is there a reason that GM kind of sat back on the cell chemistry in terms of charge speed? Is that a decision that was made for ensuring a long life for the battery pack, or is there another reason behind that?
Yeah, it's pretty common to talk about peak charge rate. It's a nice round number. It's easy to compare a vehicle to another vehicle. But really, it's more complicated than that. It's a charge curve, and that curve is heavily dependent on the state of the charge. It's dependent on the temperature of the battery, among other factors, right? So we designed that curve to, we balance the performance of charging and giving our customers the most added range we can in a short period of time. But we're balancing that with the longevity of the battery. And what we did for model year 20 was we didn't change that peak at a low state of charge, and the mild temperatures. We didn't change that peak. What we changed was the shaping of that curve going forward between 0% and 100% of the battery state of charge. So what that allowed us to do was at 100 miles of range in the first 30 minutes on a depleted battery in mild temperatures. And in cold temperatures, where we really saw the benefit, where we actually increased the number of miles we could add in the first 30 minutes, we increased that as high as 150%, just because we were able to use more of that charging rate at lower temperatures. And that was made possible by the chemistry changes we made, reduce the internal resistance within the battery, and that allows us to flow energy into the cell just as it allows us to flow energy out of the cell without it essentially fighting itself with resistance. So we got it there, and we also were able to learn quite a bit from our thermal cell management controls. And we learned that over the previous 3 model years and our EVs before. We learned a few things from aging packs and packs that were high mileage and had gone through a number of DC fast chargers. So we evolved over time, but we also reduced the internal resistance. So our goal was to reach the 100-mile mark in 30 minutes, and we were able to do that just with the chemistry change and some control changes.
And internal resistance is something that I think a lot of people don't understand, but it is essential to a battery pack's abilities and its lifespan. Obviously, lowering that internal resistance means that essentially you can put a higher amount of power into the pack before it starts to misbehave, before it wants to start to heat up. It's a very kind of basic explanation of it, but when you try and put a high current through or a high amount of power through a high resistance circuit, you're just going to turn that to heat rather than actually turn it to useful energy. And so that's why you were able to change that charge curve for the better. I think something else that you said that is really worth reiterating here, Jeremy, is that, the rapid charging experience is so subjective to the end user, because it's dependent on how hot it is outside, how warm the cells are inside your car, which is dependent on both external temperature and how effective the cooling system is, if it's got either an active or a passive cooling system, depending on how effective that cooling system is. But it's also going to be dependent on the age of the battery, how you just drove that last segment. If you absolutely hammered the pack, it's going to charge at a different rate than if you drove really gently. And also what the charging station itself is capable of, because some charging stations are not capable of charging at the maximum power rate of the car, and that will alter the charge curve as well, won't it? And so it's very difficult to kind of subjectively observe major changes like this in the real world sometimes, isn't it?
It is, because DC fast charging, it's nice and it's convenient when you need it. But it kind of stems from the gas station mentality of, my vehicle is low on energy. I have to stop and pick up some new energy, and I want to do it in a rapid manner so I can get back on the road. Where if you actually drive an EV and you have a charging system at home, which many of our customers do, it's more how you live with your electronics, how you live with your cell phone or your laptop, in that you charge in the evening, and every time you leave for work or leave for school or wherever you go, you're always at a high state of charge. And when I drive one, and I have one that I drive quite a bit, I almost rarely go below 50% state of charge, to the point where I have to force myself to not charge it at night so I can see what happens when we get to a lower state of charge. Because if I plug it in every night, I would leave at 80% higher state of charge. And just like I do at night with my cell phone, I put it on the nightstand and wirelessly charge it, and in the morning it's 100%. I repeat the next evening. So DC fast charging, it's really nice, but all those factors come into place. And the other thing you got to think of is, if you're like I drove to Pittsburgh a couple of weeks ago, if you go and charge at a faster rate, the price is not linear. It goes up with rate. So if you go back to the gas station analogy, and I wanted to put 26 gallons into a Suburban at the same timeline that I put 12 gallons into a Malibu, the price of the gas would go up. and I don't think anybody would want to sign up for more expensive gas. So lots of factors in play there.
Obviously, something that you are looking at with obviously future vehicles from the GM stable. We know that there are future electric vehicles in development. We know that obviously GM's Ultium battery system is truly a step up from what we're seeing in the Bolt EV. And I don't mean that in any kind of disrespectful way, but obviously it's a generational improvement. There are technologies coming down the pipe from GM for use in Ultium batteries that are not in the current Bolt EV batteries. Things like the modular replacement, the wireless monitoring of cells. All of that technology is coming down the line.
Yeah, we like to look at it
Do you think
it's an evolution, right? Like we stepped from the Spark EV to the Bolt EV, and now we're going into Ultium. And the technology is going to change, the chemistry is going to change, and quite frankly, the world's going to change. There's going to be more of a charging network out there where the use of a DC fast charger will be more practical and come into play in more aspects of our life.
And I think, we've got the situation now where we've got batteries. Obviously, GM's known pretty well now for its longevity of its battery pack. We've got Volts that are still on the road today with 100, 200,000 miles on the clock, whose batteries are still going fine. Obviously, they are range extended electric cars. We've got Bolts on the market now with 100,000 miles that are off fleet vehicles that still seem to be performing pretty well. And that's been a real bonus for GM based off of some of the competition that struggled to keep their battery packs healthy over long periods of time. I want to finish the interview, Jeremy, by talking about some of the surprises that you've had working on the Bolt project, either things that the vehicle is being used for today that you never assumed it would be used for, or things that you've learned from owners. You talked earlier about you learned a lot from the truck days of talking to truck owners about what they do with their cars and their trucks. And obviously you're doing the same now with Bolt. I was on a road trip earlier this year where I ran into a company car. It was sign written for a yerba mate tea company. They'd actually removed the rear seats and turned it into a small delivery vehicle. What kind of things have you come across in terms of Bolt uses that have surprised you?
That's a great question, because I've been known to go through our fan sites, fan pages, Instagram, all these things, and I kind of look for these things, and that's a trait I kind of learned working for Full Size Truck. I like seeing what creative things people did with them. They put lifts on them, they lowered them, they painted this, they painted that. It was always interesting. So from a BEV standpoint, it's been equally, or if not more, interesting to watch people use them. For one thing, our EPA estimated range, people don't take that as a fact, they take it as a challenge. They're always trying to beat it, and when they do, they take a picture of it and they post it. And in some cases, I think these folks are driving around without air conditioning and without heat, and that can't be me. And I certainly can't roll through stop signs, but it's impressive the competition it's become to get the most out of a single charge. So it's fun watching that. One of the posts that I saw in the recent weeks was someone who filled their Bolt EV with sod, like top to bottom, front to back with sod. It was an impressive photo, but you got to wonder how getting that sod out and getting the dirt out of it was going to be a chore in itself. It's probably as much of a chore as laying that sod down. Another one of my favorite stories was a gentleman in Texas, I believe, who got an SUV integrated tent, and he went out camping with his dog and attached this tent to the hatch of the Bolt EV and basically made himself an electric RV. And quite frankly, I've been inspired by that and currently shopping for one of those myself. And I'm hoping
too, actually.
I'm hoping to send some pictures of myself doing the exact same thing. So always interesting to see. Some are trying to maximize efficiency and some are maximizing utility. And we have our light commercial vehicle version of the Bolt, where You can take out the rear seat and put in a load floor. And people use them for delivery vehicles, especially in urban areas. So I always like seeing those vehicles all decorated with company logos and full of products. So
and I think I have one hope, which is that we're going to see a performance version at some point. I've always maintained that the Bolt EV is like an old-fashioned hot hatch from the 1980s, obviously being British by birth, growing up in the 80s and seeing, you know, the birth of the hot hatch world. The way that the Bolt drives, and there are some issues with the way it behaves, which is characteristic of its size and its drivetrain rather than it being electric. Like it's a front wheel drive car. It tends to torque steer sometimes if you're a little bit harsh with it. You know, you put your foot down and you have to kind of fight the wheel sometimes. But that's been the same for every single hot hatch I've driven. And I have to say, it gives me that hot hatch feel. And I'd love to see a high performance version, maybe an all-wheel drive or just a drag version. Do you know if anybody has been tempted to do that in the customer world?
Well, in the customer world, we've seen a couple projects. I don't know that I can speak to those, but a lot of our rides we will have an autocross, and we let people, and maybe you were one of them in Portland. We let people drive around, and it is an inspiring car to drive at times, and I think everybody would want a little more of that.
Yeah, absolutely. Well, thanks for joining me, Jeremy. It's been a pleasure to talk to you, and good luck on your future endeavors. I know that you're working on some new cool stuff that you're not allowed to talk about because, you know, that's the way the world works. I'm working on cool stuff I can't talk about. But thank you for joining me and talking about the Bolt and the development up to this point. I hope you do stay with electric vehicle programs, and I hope that everybody watching stays watching Transport Evolved too. I just want to thank everybody who's scrolling by. They are our charged up patrons. Obviously, thanks very much also to our $50 a month patrons. They really do help our channel grow and make sure that we can bring you great content and, you know, ensure that we have all the bandwidth and all the equipment we need to make sure that interviews happen, whether they're socially distanced or not. I'll be back soon with more great content for you all to enjoy. But until then, thanks for watching. Don't forget to be kinder and better and smarter. Wash your hands, stay healthy, and as always, keep evolving.